Okay, so here are the rules that we've learned. These are the rules that you need to have memorized for just being able to do the problems that you need to do fluently. Most, if not all, of these rules are in the formula booklet, but again, the better you know them, the more you will be able to see the connections that you need to see in order to solve problems and stuff. Okay? So what we want to look at today actually is how to deal with that plus C. How do we deal with that plus C?
I like where this is going.
Okay? So what we're going to be doing is we're going to look at situations where we are given a point on the original function. Okay, so here, notice what we have. We're told that the derivative of f is this function 2 sine x minus radical x. We want to figure out what the original function f of x is. Okay, so initially you guys are thinking, okay, well, if I have the integral of the derivative of a function, that's going to give me the original function plus some constant. Okay? So as I'm thinking about this, I'm taking the integral of 2 sine x minus, and I'm going to write that as x to the half power, because that's easier to work with integrals. And now I can actually do the antiderivative of this. Okay, so what is the antiderivative of 2 sine x?
Negative 2 cosine x?
Yeah, the antiderivative of sine is negative cosine, so that's going to be a negative 2 cosine x. Okay. Minus, what's the antiderivative of x to the 1/2?
2/3 x to the 3.
Sure.
Okay, we add 1 to the exponent and divide by the new exponent. So dividing by 3/2 is the same as multiplying by 2/3. Okay, and then we throw on the plus c, and that is our function. Okay? But that is just a general solution. Okay? Any constant would give us an f prime that was 2 sine x minus radical x. However, here's where we have this extra bit of information. We were told that f of 0 equals 4. Okay? So, now what we're going to do is we're going to say, okay, well, when x is 0, so I'm going to have negative 2 cosine of 0 minus 2 times 0 to the 3/2 over 3 plus c, that will equal 4. Okay? Now, just a note here, unless you're specifically told that you are using degrees, like that one change in area problem we did a while back, you always assume that you're dealing with radians, okay? And in calculus in particular, we're almost always dealing with radians, okay? So, what's cosine of 0?
Cosine of 0 is 1.
1? Okay, so negative 2 times 1 is negative 2.
Minus 0.
Minus 0, that whole thing there, 2/3 of 0 to the 3/2 power is 0.
Plus 6.
So plus c. So now I can say that, alright, c has to equal 6. Okay? C has to equal 6. So this means then that my answer that I'm looking for here is f of x equals a negative 2 cosine x minus 2x to the 3/2 over 3 plus 6. That's the particular solution for this problem.
Is this what AP deals with more?
AP does deal with this. This is actually, we could actually consider this what we call a differential equation. An equation that has a derivative in it is technically a differential equation. If we wrote this as dy dx, and then what we would do is multiply both sides by the dx, and you have the dx here, and you integrate dy, and you get y, and you integrate the other side that has the dx, and you'd be doing what we just did here. And then they call it finding the particular solution of the differential equation. Okay, so that's something that they do a lot of throughout with a variety of different differential equations. And then if you get to college and you finish all the calculus that they have, you can take differential equations,
Yep,
an entire course on it.
I'll do that.
Okay, so
That sounds really hard.
well, you work up to it. It'd be,
Yeah.
they don't throw you in there your freshman year.
I feel
So
like if you're there at that point, you'll if you're doing it, you're going to be able to do it. If you're taking
Yeah.
the class
yeah.
at that point.
All right, so here's another case, kind of extending this a little bit further, okay? Notice here I'm giving the second derivative of f as 12x squared minus 4, and then I'm given two different points. But notice here, one of those points is a point on the first derivative, the second point is a point on the original function. So what am I going to have to do in this case? Anyone?
Integrate twice.
Integrate
So
twice.
you do one, and then you plug in the negative one for that first one, and then you do it again.
Okay. Yeah, we're gonna, if we have the second derivative, we're gonna have to integrate 2 times to get back up to the original function. Okay? So, let's work this out here. If I do the integral of the second derivative, 12x squared minus 4 dx, okay? The integral of 12x squared is 12x cubed over 3. Excuse me. Minus the integral of 4. What's the integral of 4?
4x.
4x. Okay? By the way, side note,
Plus c.
the constants really are the power rule. 4 is just 4x to what power?
1.
No, then it would be 4x.
0.
It'd be 4x to 0, right? So if I add 1 to the exponent, now it's 4x to the first divided by 1. Okay, so you just end up with 4x. So you can either memorize the constant rule or just think of it as a power rule when the power is 0. Okay, that's just a side note. Okay, so here we have this plus c. Okay? And you notice, since I'm going to be doing this twice, I'm going to call this C1. Alright? It is important to recognize that the constants on the 2 times will not be the same necessarily. Okay, so
Right.
you would want to just differentiate between them. Now, you have an option here. You can go ahead and figure out what C1 is right now, and then do the integration the second time. Or you can do the integration the second time now, and you'll have a C1 and a C2, and plug in both of these. The thing with that is, though, is that you would have to, you're going to end up having a system of equations, okay? Now, there will be occasions where you have to do it that way because they aren't going to give you a point on the derivative and the function. They might give you 2 different points on the function. And in that case, we can't figure out C1. We're going to have to do the derivative or the integral the second time and do a system of equations. Since we can, though, here it's going to be better for us to go ahead and figure out what C1 is right now, okay? Because, all right, here we have f prime of x. So we are told that when you plug in 0 to f prime of x, so it's 12 times 0 cubed over 3, which I should have reduced that. That's 12 over 3 is 4. So 4 times 0 cubed minus 4 times 0 plus c1, we're told that that equals negative 1. So of course that means c1 is negative 1. So now I know what my first derivative is. F prime of x is 4x cubed minus 4x minus 1. Okay? So now what?
Now you have to find the antiderivative of that.
Yeah. Okay? So let's integrate the first derivative. F of x is going to be the integral of 4x cubed minus 4x minus 1 dx. Okay? So now we have 4 times x to the 4th over 4 minus 4 times x squared over 2 minus 1x plus a different constant, c2 we'll call it. Okay? And of course we can reduce those. So we just have x to the 4th minus 2x squared minus x plus c2 equals the f of x. Okay? So here's where we can use the other point. The other point that we were given is that f of 1 equals 4. So when I plug in 1, this whole thing equals 4. So 1 minus 2 minus 1 is negative 2. Negative 2 plus c2 is 4, so c2 must equal 6. And now we know our final answer. Our final answer, f of x, is going to equal the x to the 4th minus 2x squared minus x plus 6. That is the particular solution for the given conditions that we have where f prime of 0 is negative 1 and f of 1 is 4. Okay? There are a lot of steps. Okay? But notice you're doing the same process twice here. Okay? You just do the same process twice. If they gave us the third derivative in 3 different points, then we just do it 3 times.
Yay!
Fifth derivative of 5 points.
Yeah.
20th derivative.
Okay?
Is that
So
what
it's no harder, it's just longer.
we take differential equations in college is like 20 derivatives.
We don't usually deal with tedious stuff like that, but anyways. So try this one on your own. Here I give you f prime of x is x cubed minus 2x squared plus 3, and I tell you that f of 0 equals 2. So take a few minutes here, try this one on your own. Alright, so just to run through this real quickly, if we're doing the integral of x cubed minus 2x cubed over 3, oh wait, sorry, I'm half writing it down and half doing the integral. 2x squared plus 3 dx, we get x to the 4th over 4 minus 2x cubed over 3 plus 3x plus the constant, and since it's a polynomial, we know that when we plug in 0 is the y-intercept. The y-intercept is the constant at the end, so we can take a little bit of a shortcut here, and it's x to the 4th over 4 minus 2x cubed over 3 plus 3x plus 2. Okay, again, that's our y-intercept, so that's going to just be the constant because it's a polynomial. Be careful about things that have trig in them or maybe logs in them or e to a power, something like that, those ones aren't going to work out this way. But any polynomial ones, when you plug in 0, that's going to be your constant. Okay? Alright, so that's it. I've got some practice for you. These ones are just some more practice, just using the basic rules here. Okay, then here we have some examples of using a point to get a particular solution and solve for C. Okay, we have several examples like that for you to work through. Okay, here's even a couple at the end where you're given the second derivative. And by the way, notice the very last one does not give you a point on the derivative. It gives you 2 points on the function. So what did I tell you earlier you would have to do in that case?
System of equations.
A system of equations.
Integrate twice as every system. Okay.
Yeah. Make sure you use like C and D or C1 and D2, C2 or something like that to differentiate between their two constants on your two integrals. But you can practice one like that. Okay? All right, cool.